Good day, everyone. So now we are down to the chapter 12, which talks about the global climate. But before that, let's have a recap first about the previous topic that was all about a hurricane. So, a hurricane, according to the report, is an intense storm of tropical origin with sustained winds of at least 64 knots and with considerably higher gusts. So, hurricanes are composed of intense convective clouds. That's why we experience a thunderstorm that sometimes grow to over 15 kilometers or 50,000 feet in height. So, in other words, hurricanes are powerful, rotating storms that develop over warm tropical or subtropical ocean waters. They are characterized by strong winds, heavy rainfall, and storm surges that can cause significant damage when they make a landfall. So, now since we are done recapping about the previous topic, let's go down to chapter 12, which is all about the global climate. So we have the contents here. First is a world with many climates. Second is the climatic classification or the Köppen system and the global pattern of climates. So next, we have here our learning objectives, which is first to describe the major types of climates found around the world and the factors that influence them. Next, we have to identify and differentiate the characteristics of the major Köppen climate groups. And last but not the least, we have to explain the global distribution of climate zones based on temperature and precipitation patterns. Global climate refers to the average weather conditions such as temperature, precipitation, humidity, and wind patterns across the entire Earth over a long period of time, typically 30 years or more. So, this involves such factors, right, as what you can see here in my PowerPoint, that it involves temperature, precipitation, humidity, and even wind patterns. So this will determine the overall environmental conditions on Earth influencing ecosystems, agriculture, and human activities. So it is very important as well for us to understand global climate because it helps in predicting climate change trends and planning for natural disasters. Now I have here an illustration. So this is somehow a map that shows the average annual sea level temperatures across the world. Now, na mga color, right? That different colors or color zones, we call it the color zones. So the red and orange areas represent hot regions, mainly near the equator. As what you can see, it is in the middle. So naana siya sa duol sa equator. While the green ones and blue areas represent cooler regions, with the darkest blue marking the coldest areas near the poles. So as what you have observed here, the equator have a 0-degree latitude, right? Because it is the hottest zone due to receiving direct sunlight all year. So the temperatures here gradually decrease toward the poles, over 90 degrees in the north and south. So next we have the global temperature patterns. So what you can see here, the global temperature patterns, this is where the equator receives the most direct sunlight year-round, making it hotter than other parts of the Earth. So this uneven heating creates temperature zones. So first we have tropical zones, or hot, which can be found near the equator, experiencing year-round heat. Second, we have temperature zones, or mild. So this is found in the mid-latitudes with seasonal changes. For the polar zones, or the cold areas, this is found near the poles, experiencing extreme cold most of the year. Now, for the global precipitation patterns, high rainfall occurs near the equator due to rising warm, moist air that forms clouds and rain. So, for low rainfall, it is common in deserts around 30 degrees north as a latitude, where air sinks and dries out. Now, for the mid latitude, these are the areas that may have moderate rainfall, while polar regions are dry and cold. Now I have here another illustration that shows how air circulates globally, influencing the precipitation. So the ITCZ, or the Intertropical Convergence Zone near the equator, this warm air here, the warm air rises, causing high rainfall, while in subtropical highs, wherein naa siya 30 degrees north and south, this is where the air sinks, leading to dry conditions and deserts. For the polar front, where 60 degrees in the north and in the south, here the air rises, bringing precipitation in mid-latitude areas. For the polar high that have 90 degrees in the north and in the south, the air sinks, causing cold, dry conditions. So the key concept here is that rising air is equal to wet climates, while sinking air results dry climates. Okay, so the Climatic Classification Köppen system in year 1918. This is one of the most widely used systems to classify climates based on temperature and precipitation. Now, letter A, we have the tropical moist climates, wherein this area experience hot and wet all year. The dry climates, group B, we have here the deserts and arid regions with low rainfall, since dry man, right? Now for letter C, we have the moist subtropical mid-latitude climates, wherein this area will experience warm summers and mild winters. Now for letter D, we have moist continental climates, where this area will experience warm summers and cold winters. For letter E, we have the polar climates, extremely cold with ice or tundra. So this is what this area will experience if they have a polar climate, extremely cold with ice. And last but not the least, we have the highland climates that vary with elevation. Now let's dig on this, if what each of these climates really refers to. But first, let's figure out what this illustration stands all about. So this map combines the Köppen classification with global climates controls. We have here the color codes. Again, the green represents tropical climates, the yellow or orange for dry climates, blue for moist climates with mild or cold winters, purple or white for polar climates, and brown for mountains or highlands. So, kanang na ay mga red dashed lines shows how the ITCZ shifts north and south between January and July, while high and low, kanang letter H and L, pressure zones na sila to indicate areas of stable weather and stormy or rainy conditions. So in other words, kanang H nagrepresent na siya stable nga area, stable weather in a certain area, while the L represents a stormy or rainy conditions. Now we have here the global pattern of climate. Okay. So the global climate patterns refers to how temperature, precipitation, and atmospheric conditions vary across the Earth due to its shape, rotation, tilt, and geography. So, kaniyang mga patterns, they create distinct climate zones that influence ecosystems and human lifestyles. To start with, the tropical moist climates. These climates are found near the equator and are characterized by high temperatures, consistently warm year round, and abundant rainfall. So, the vegetation here includes rushed rainforest and tall grasses. So, there is a little temperature variation, but precipitation can vary by season. So, our very own country, which is the Philippines, is an example of tropical moist climate. So we have here, we call this the climate graph that shows high average temperatures year round around 25 to 27 degrees Celsius. So as what you can see in the figure, the precipitation bar graph is tall and spread throughout the year with peaks indicating wet seasons typical of savanna regions. So that is all about the tropical moist climates. Second, we have dry climates. So these areas receive very little precipitation and can be hot, mostly in deserts, or cold or semi arid. So vegetation is sparse, including shrubs and drought-resistant grasses. So there's a large temperature range between day and night in this area where they experience dry climates in between seasons as well. So I have here another figure, a climate graph that shows low total precipitation around 350 millimeters, with most months receiving less than 50 millimeters. So the temperature line peaks in summer, indicating hot and dry conditions like those seen in desert climates. Letter C, we have moist subtropical mid-latitude climates. So here, these climates occur in subtropics and have mild winters and hot, humid summers. Common vegetation includes broadleaf forest, shrubs, and crops like citrus. So rainfall here is well distributed but often peaks in summer due to convectional storms. As what you can see in the climate graph here, it shows the data from Mediterranean and humid subtropical climates. So the Mediterranean graph, so what you can see on the left side, shows dry summers and wet winters, while the humid subtropical on the right has rainfall more evenly distributed with warmer summer temperatures. Now let's move on to the moist continental climates. So here, it is found in the interior of large land masses. So kaniyang mga climates have cold winters and warm summers, and marked by 4 distinct seasons, with deciduous forest being common. So here, the precipitation is moderate lang all year round. So another climate graph here displays the greater temperature variation than subtropical climates. So precipitation is fairly steady, supporting the vibrant autumn foliage shown in the photos, what you can see. Now let's go down to the polar climates. So these regions are near the poles, is what I have tell you earlier, experiencing extremely cold temperatures all year round. So there is very little precipitation, mainly snow, and a tundra or ice-capped landscape. Limited lang ang vegetation here, like mosses, lichens, and dwarf shrubs can be found in tundra zones. So another climate graph that shows a very low temperatures, rarely rising above freezing. So the precipitation is minimal lang here, and the red temperature lines remain mostly below 0 degrees Celsius throughout the year. And last but not the least, we have the highland climates. So these climates occur in mountainous areas where altitude affects temperature and vegetation similarly to how latitude does. So the higher the elevations, the colder, supporting different vegetation zones from grasslands at the base to alpine tundra at the peak. So the rainfall patterns vary based on slope and exposure. So dili na to ma-identify ang windward or leeward sites. So I have here a diagram that illustrates vegetation changes with elevation from tropical lowland zones, kanang grassland, rainforest to temperate forest and alpine meadows as you go higher. The figure notes that altitude affects mirror latitude, meaning climbing a mountain is like traveling from the equator to the poles. So the 6 major climate types reflect the incredible diversity of Earth's natural system. So each climate, from the lush, rain-soaked tropics to the frozen polar regions, shapes the way plants grow, animal lives, and humans adapt. So these climates are not just weather patterns, they are life zones that influence culture, agriculture, and daily routines. So understanding them helps us appreciate how interconnected the planet is and how environmental changes in one zone can ripple across the globe. So together, they remind us of Earth's delicate balance and the importance of preserving its varied ecosystems. So I hope you learned something, and I hope you reflected within yourself of how important it is to understand what global climate is all about, because this doesn't just talks about a one specific region, a one specific place. It talks about how interconnected the places and the climates are globally. So that's all for my topic about the global climate, and I have attached the Google Forms for you to answer. But don't worry, you can really answer it if you listen to what I have discussed. So thank you everyone for listening.